Hello there. In this video, we are going to take a look at another mechanism in Q that has to do with simulating, not until some maximum time has elapsed, like in the previous video we did, but in order for there to be some set number of customers or whatever your thing that flows in the network to have entered through and then completed, as in gotten to what's called the exit node, which is basically that they've left the system as we might imagine it. So let's create a script file here. Actually, first thing is let's activate our virtual environment that just has Q and some other things installed. And then we'll go how to simulate to number of completion. We'll put that for now, might change it later. So let's import Q, and let's set that we've got we need basically a model first. So let's define a model. Network is equal to Q dot, not equal, assigned to. We're going to do the create network again, and we'll set up our arrival distributions. I'm going to keep these examples simple because I don't really want to spend time elaborating on model design until we get into some modeling problems. So for the moment, I'm just going to pick some examples from the documentation. We'll also have, so we need our arrival distributions, our service distributions, and we also need number of servers. Notice here I'm not putting a lot of thought into this really at the moment. This is, strictly speaking, this is an MM3Q, which could pick us some other Q. Queuing model, but that should serve our purposes for now. And then let's say we're going to set a seed, because we probably should. We'll just use the same one as the documentation of a seed of 1, and we will create a simulation object, q.simulation, and we're going to pass in our network model, which happens to be the name of the argument network in the simulation class, but that's fine. Okay, so we've got our network model where we've set the seed, so we're going to do only one particular pseudo-random state, and we're going to have our simulation object that runs the simulation. The next thing, and this is really to the crux of what this video is about, is we're going to change up how we do simulation. So we're going to do simulation until max customers, and we're going to change the method from the default. Actually, no, sorry, I tell a lie. This is the default, but what we've changed since last time is we're not doing simulate until max time, which is what we did before. Now we're simulating till a maximum number of customers, which it actually just so happens to be the case. I forgot that the default is complete, but to be explicit, one might even say to be complete, we're going to put complete. So what does complete actually mean in this context? Because there's actually different methods we're going to look at, and so we need to define these things. When we say that the method is equal to complete, it means that some target number of customers or whatever is flowing in your network has reached the exit node, and that's normally because they've gone through the entire system. We do actually need to set what that number is. We could set it as a constant number of customers, and we could say, I don't know, let's say 30, and we need to put that in here. So that is the max customers argument, and we will put in our max customers. Oops, let's go back and let's maximize that. So number of customers. Need to keep track of my own variable names here. And it is max customers, not max customer. Okay, so it's a little bit different from having a until max time, because in the until max time, we don't know how many customers are actually going to go through our network, and we'll just keep calling them customers for now. We don't know how many are going to go through in some fixed amount of time, but we can go the other way of simulating until a fixed number of customers have gone through the service or the set of services, but then we don't know how much time that's going to take. So let's take a look at, what did we call this tutorial? Max completion. So we didn't print anything. We should probably print something like, let's get the records. And we'll go simulation, get, oops, made that a little bit too small on you guys, get all records. And then what we might do is we can print out a list comprehension here just to take a look at what we are obtaining. Let's grab, it's not going to be the most pretty expression, but we'll just go R4, R in records. So R here, I'm just abbreviating for record. If R dot record type is equal to complete, service. We want to make sure that we're actually grabbing the ones that were in fact served and didn't leave the network for some other reason, which can happen. Okay, so it says it was not closed, but I don't believe it. It looks very closed to me. Record type, length, print. I think it's possibly just delayed. Should be 2 on each side. It appears to be. Let's just run it and see what if anything breaks. So I accidentally put only a single equality, and that is assignment, but I actually need to do the Boolean evaluation, which involves the double equal. There we go. So 30. And if we wanted this as like a control check, we could do something like an assertion that the number of customers is in fact equal to the desired target length. Should not raise an error, and it does not raise an error. So that's our first look at controlling for the number of customers that have been completed. There are some similar methods that we're going to look at, but completed is kind of the intuitive one of we want to make sure that we're looking at how many were actually served. So with that, I will catch you in the next video. Take care.